extracting metals towards the top of the activity series. Metals high up in the reactivity series, they are very reactive. They cannot be obtained from their compounds by heating with carbon. Carbon will not be able to reduce the oxides of sodium, magnesium, calcium, aluminum, etc. to the respective metals. What is the reason? The reason is that these metals are highly reactive and these metals have more affinity for oxygen than carbon. So carbon will not be able to remove oxygen from the oxides of these metals. Or in other words, carbon will not be able to displace the metals from their oxides. Because sodium, magnesium, calcium, aluminum, etc. or the metals higher up in the reactivity series have greater affinity for oxygen than carbon. Now, how to obtain these metals? These metals are obtained by electrolytic reduction. The reduction method used to obtain these metals is electrolytic reduction method. For example, sodium, magnesium, calcium, these are obtained by the electrolysis of their molten chlorides. For example, consider sodium chloride, molten sodium chloride. This sodium chloride will dissociate into sodium ion and chloride ion. Sodium ion is the positive ion, or it is also known as the cation, and this cation goes to cathode. Cathode is the negatively charged electrode. Chloride ion or the negative ion is also known as anion, and this anion goes to anode, and anode is the positive electrode. The reaction that takes place at the cathode is sodium ion accepts one electron and converts to neutral sodium atom, which get deposited at the cathode. Two chloride ions lose two electrons, form chlorine gas, which is liberated at the anode. So at the anode, chlorine gas is liberated, and at the cathode, sodium metal is deposited. Next is refining of metals. Metals produced by various reduction processes, they are not very pure. They contain impurities which must be removed to obtain pure metals. The most widely used method for refining impure metals is electrolytic refining. Now, what happens in electrolytic refining? Many metals like copper, zinc, tin, nickel, silver, gold, they are refined electrolytically. In this method, the impure metal is made the anode and a thin strip of pure metal is made the cathode. And solution of metal salt is used as electrolyte. On passing current through the electrolyte, pure metal from the anode dissolves into the electrolyte. An equivalent amount of pure metal from the electrolyte is deposited on the cathode. Soluble impurities go into solution and insoluble impurities settle down at the bottom of the anode and are known as anode mud. For example, here electrolytic refining of copper is shown. The electrolyte solution is acidified solution of copper sulfate. Copper sulfate dissociates to give Cu2 plus ion and sulfate ion. Anode is made up of impure copper and cathode is made up of thin strip of pure copper. Cathode is the negative electrode, anode is the positive electrode. On passing electricity through the electrolyte solution, what happens? Copper from the anode goes into the solution as Cu2 plus ion, giving 2 electrons, and same number of Cu2 plus ions from the electrolyte solution go to the cathode, accept 2 electrons and are deposited on the cathode as metallic copper. So at the anode, this is the reaction at the anode. At the anode, what is happening? Copper from the anode is going into the solution as Cu2 plus ion and losing 2 electrons. And at the cathode, the Cu2 plus ions from the electrolyte solution, same number of Cu2 plus ions from the electrolyte solution are going to the cathode, accepting 2 electrons and changing into metallic copper, which is getting deposited on the cathode. And whatever soluble impurities are there, they go into solution and insoluble impurities collect below the anode as anode mud. At the end of this refining process, pure copper will be deposited from the anode to the cathode. At the end of this process, pure copper will be obtained at the cathode.